Hello and welcome to Industrial IoT Live Lab here on Industry4.tv. So today we are going to be showing you how to build a Sparkplug Edge of Network node on a Raspberry Pi using Java. So this actually is a series of weekly episodes that is designed to help you learn or explore the tools and techniques for creating the connected factory. So today I'm joined by Jens. So I'll ask Jens to introduce yourself.
Yes, with pleasure. So yeah, hello from me also. So my name is Jens Deters. I'm a colleague of Kutzai. We're working together at HiveMQ. I'm responsible for the professional services team at HiveMQ. Also I'm the author and the founder of a tool we will showcase today. It's called MQTT FX. It's an MQTT testing and analytics tool. And yeah, we will use it through our demo. And also I am the author of the Sparkplug client implementation or Edge Node implementation we will also showcase today.
Perfect.
Eventually, that's the reason why Kutzai has invited me here today.
Perfect. Yes. Yeah. So Jens is our Sparkplug expert here. So he's going to be really diving deep into the code implementation to show you exactly how everything is, all the pieces have been put together, and also how you could also adopt that framework to apply it to your own hardware platforms that you need to implement that Sparkplug functionality on. Okay. So again, let's get started. Today we're going to be talking about and demonstrating to you how to build an MQTT Sparkplug Edge node on a Raspberry Pi using Java, right? So, but first of all, I think it's also very important to kind of like really quickly talk about what a Sparkplug Edge of Network node is for some of you who are not familiar with what that is. So again, if you've got questions throughout this whole session, feel free to drop them on the chat. We're going to address all your questions as we go through this demonstration. So basically, in a Sparkplug architecture or a Sparkplug network, we've got different types of components. So we've got what is called an edge of network node, which is really a gateway, a device that is capable of communicating via an MQTT network. So this is the device that in most cases sits right in the middle between your legacy devices and your MQTT broker. So it takes care of converting from like your legacy protocols. So if you've got a device that talks Modbus on one end, your edge of network node is that gateway that is responsible for performing the conversion and publishing into the MQTT broker using Sparkplug on behalf of all the devices that are not able to participate in that network. And then we've also got a primary host application. So a primary host application really is what typically a SCADA system would do in a SCADA environment. It is responsible for sending commands to your Sparkplug edge of network node, and a Sparkplug a primary host application is deemed primary by the edge of network node. So if an edge of network node deems a certain host application as its primary, that's the application that is going to become that primary host. So we've also got a host application, which is not a primary host. So typically this is responsible for just like ingesting all of this information. So maybe this could be like a historian, for example. We've got Canary, which is responsible for subscribing to receive the metrics and trend all of this information and also persist it in the database. So what we're going to be focusing on today here is the implementation of the edge of network node, or in short, what is called an EON, right? So this is the architecture that we're going to be demonstrating for you today. So I've got a Raspberry Pi device here with me that has got a Senset, right? And Jens also has got one in his lab. So basically, we're going to, we've already deployed the code on these Raspberry Pi devices. So we're going to show how it connects, and then we're going to show you all the Sparkplug operations, birth certificate generation, matrix generation, and also we're going to show the aspect of how to send commands. And more importantly, we're going to dive into the code and really show you exactly how all of that is implemented and go through the project so that you can also implement it by yourself. So basically, in this architecture that we're going to demonstrate today, what we have, as I've already explained, we've got these two Raspberry Pis. One is sitting here in my lab. The other one is sitting in Jens's lab. So it's also generating some telemetry. So this sense head, it's got temperature, humidity, accelerometer, pressure, and all the different kinds of sensors that you'd need. So this will be really easy for you to replicate. If you have a Raspberry Pi, you simply just need to buy a sensor. If you need to test this first before you deploy it on your hardware platform of your choice. So basically here, what we're doing is we're using these sensors to simulate the compressor parameters. So my edge of network node is simulating the parameters for a compressor one. So, and then the one that Jens has got is simulating the parameters of compressor 2. So these are real sensor values that are going to be collected via the Raspberry Pi on this Sparkplug Edge node. And both compressor 1 and compressor 2 are actually sitting on a production line. Like so, hypothetically, production line 1. So we're also going to show how you're able to also use the group ID and edge node ID to then kind of like categorize or group these edge nodes logically according to how they are located, or physically according to how they're located within a production line. So before we jump into the demo, what I want to show you quickly here is, because we've got a HiveMQ Cloud MQTT broker, which is acting as our central cloud based broker where we're publishing all of these Sparkplug messages to. So this is a HiveMQ Cloud instance. So this is something that you can create for free, right? You can connect up to 100 devices to it if you're using the free one. As you can see, I've got 2 clusters here. No credit card required. You just simply go to HiveMQ Cloud, HiveMQ website, go to cloud, sign up, and then you've got a cluster that has already been created for you. So this is the cluster that we're actually going to be connecting to from our Sparkplug Edge of Network nodes today. So I'm just going to refresh this. Okay, and then I'll go into my cluster. So as you can see, I've got my cluster URL address here, right? And then on this interface also, you're able to set up your access credentials. So as you can see, I've got Sparkplug Eon 1 that is set up credentials, which is my Sparkplug Eon that is sitting here on my lab. And then Sparkplug Eon 1 is the one that the Raspberry Pi that Jens is got on his desk there, that is going to be publishing to this MQTT broker. So I've already copied these host name and credentials onto my Sparkplug Eon. But again, we're going to show you how that configuration workflow goes. So maybe let's quickly jump to that. Just a second while I pull this up. Okay, so what you're looking at, again, we're going to show you how this configuration file is created and how it is deployed and built, and also sent to your Raspberry Pi so that it can be used as a source of configuration for your Sparkplug Edge of Network node. So we're going to show you all of this information. Now, first of all, here, what you can see is that one of the properties here is the name, the device name, which is what you need to put on your Sparkplug Edge of Node. And here we've got the scan rate of 1000. So another interesting thing that we're going to show you again here as part of this demo is how you can actually send commands from MQTT.fx to a Sparkplug Edge of Network node. So one of the things that we're going to show you how to send commands to is to adjust this scan rate. So currently this Sparkplug is configured, this Sparkplug Edge of Network node is configured to read data from the sensors after every 1000 milliseconds. So we're going to show you how to send commands for you to adjust this value. And then this year I've got broker details that this edge of network node is using to connect to the HiveMQ Cloud cluster. And then we've got this connection information, the client ID. We're using a TLS a connection, and then we're also using a simple authentication. The username is there. And then another thing of interest here is the Sparkplug topic namespace. So this config file is what your Raspberry Pi or whatever device you're using is going to refer to for its Sparkplug topic namespace. So as you can see here, I've set my group ID to line 1, and then my edge node ID to compressor 1, and then the device ID is sensors. So this is the topic namespace that my Sparkplug edge node is currently configured with. So again, throughout this whole session, feel free to send some, put some questions in the comments below if you need some clarification on any of the issues that we're discussing here. We'll be happy to answer those as we go along. So now what I'm going to do is we're going to start with a demo, right, before we go into the actual code to show how all of that is implemented, how you can also implement it too. So basically with this demo, I'm going to fire up, start my Sparkplug Edge of Network node, my Raspberry Pi, which I've got here, right? So this is currently connected to, I'm actually currently connected to it via SSH. So maybe before I fire it up, Jens, can you show us the interface that we're going to be using to show all these metrics and all these bad messages once I fire up my Sparkplug Edge of Network node to see exactly what's happening there?
Yeah, sure. So again, as an analytics tool or a visualization tool, we will use MQTT today. So first of all, I will connect to Kutzai's HiveMQ Cloud instance with these settings and these parameters. So this is the connection profile for the connection. I will, yeah, so as you see, the broker address, the broker port, client ID, I will generate a unique one here. We will use MQTT version 3.1.1. Here are the credentials to use, and also TLS is enabled. So if I press connect here, it connects to the HiveMQ Cloud instance with MQTT 3. It's secured, and yeah, the green indicator here says that we are connected now. MQTT FX has different tabs or windows. So there's a publish window or functionality, a subscribe. There's an option that is called Sparkplug Explorer. It's a generic message explorer of every Sparkplug message traffic that is going on the broker. And here is the Sparkplug editor we will later on use to fire commands or send different commands to the different controllers or the edge of network nodes. And yeah, I think that's it's by now for the purpose of explanation. So what I will do is now to subscribe to any Sparkplug topics that will appear here to receive any Sparkplug traffic. So with this subscription, we are now armed. So I will also delete the message buffer here to delete the retained messages I've just received. So we are clear now, and MQTT is armed to receive Sparkplug messages. And I think we should switch now to Kutzai's device console to see how it looks like if you're starting the Edge of Network node on the Raspberry Pi.
Perfect. Thanks, Jens. So what I'm going to show you now, I'm going to fire up my Raspberry Pi Edge of Network node. Okay, so again, I'm already connected to my Raspberry Pi
It's
here.
a bit small font size here. Could you zoom in a bit? I think it's.
Yeah. So let us know if you can actually see what's on the screen, because I think it's showing us a small here, but it should be appearing okay on the actual screen, right? So let us know if you can actually see what's on the screen there. Okay, so maybe also let me see if I can maybe remove us from the. Okay, so it seems like it's not a huge difference, so that's okay. Okay, so I'll go ahead. So here, this is a command to start up my Sparkplug Eon here, right? So when I do that, you can see starting to run. There you go, all these device settings that I was showing you on the configuration file. We've got the data scan rate, which is set at 1000 milliseconds. We're going to show you how to send a command to change that from MQTT.fx. And then I've got the client settings, and then you can see the device is powered on. You can see that is connected to the broker, and then from there it listens on the node command message. So basically, it's now listening to receive any commands from the MQTT.fx, right? So and then after that, you see that it's actually published some birth messages. So after subscribing to receive a command, it publishes some birth messages. And then from there, it then starts to publish continuously all this sensor data as and when it changes. So maybe now we can quickly switch back to Jens to show what is seeing on the MQTT.fx to see what we can, if he's receiving anything there.
Yeah, sure. So currently, messages are already arriving at MQTTFX. So first of all, let's have a look at the first message that has been received. It's the node birth message for compressor 1. So line 1, compressor 1. Let's have a closer look. It's according to the specification. So there's a birth death sequence number, starts with value 0, followed by the commands that this device's edge of network node is able to handle. Then there are some properties containing meter information of the device, like the hardware vendor, and the operation system and the hardware model, operation system version, software vendor, and so on. Then at the end, there are this 3 sensor values that are provided by this device that Kutsai already introduced. So there's pressure, temperature, humidity, and these are the actual values when these birth message was generated. As next, there's the device birth, which is more or less empty here, because all the necessary information about this node has already been provided by the node birth message. And after that, almost every second, depending on if there are parameters that or sensor values that have actually changed, because this edge of network node implementation follows the report by exception principle. So only the changed value will be transmitted on the device data topic.
Okay.
So in the background, I will fire up this start command for my compressor 2 device, and there you go. So this is the birth message of compressor 2. And now the data messages are coming in for my local lab device here.
Okay, perfect. So now also, if you are going to be maybe implementing this on your own environment, you should be seeing the slides go on if to show that the Raspberry Pi is actually connecting and sending all of this information to the HiveMQ Cloud broker, right? So in case you want to do some troubleshooting on your end to see if it's behaving accordingly, you should see those lights lighting up sequentially. Okay, so maybe Jens, if you could, let's see if we could send some commands. You want to try to send some commands?
To the device, yes, we can do it.
Yeah.
So this is the Sparkplug editor. So I see in the commands that Paul has says that it's very small for him. So I guess he's referring to the console output of your device.
Yes.
But hopefully the MQTT window is not too small. So what you're able to create with the Sparkplug editor is basically a kind of a virtual edge of network node. So I have this Jens Lab edge of network node controller. These controller settings can be saved and loaded on your needs. So all the configuration can be stored and reused later on. Yeah, first of all, it starts with the group ID, the edge node ID, the device ID, according to the Sparkplug topic structure of the machine. Yeah, we have a bunch of pre-configured payloads, or let's say metrics. So at the end, it's a payload and containing metrics. So this editor helps to generate the proper Google Protobuf Sparkplug message. To enable this controller to actually publish messages, it established a second unique connection to the HiveMQ Cloud broker by using the same credentials and settings as the global MQTT application connection profile. But any of these controllers that you are able to create here can use their own unique connection. Yeah, well, let's send, as Kutsai already mentioned in the introduction, we would like to send the node control message to change the data scan rate. The data scan rate is an int value. So an int value in Java is of data type int32 in Sparkplug. So the name of the metric is actually node control data scan rate. A data type is int, and the value should be 5000. If I would publish this message here now, it will publish this command to Kutsai's device. Kutsai has compressor 1, and it should react on that. But before I do this, we can have a short preview of what this command is actually looks like when it's fired. It's generated by MQTT here. So it contains a timestamp of the message, timestamp of this this metric, the metric name, data type. The metadata is almost empty because we did not set a lot here, and the value is 5000. and with automatically increased sequence number and so on. So this editor here helps you to create your Sparkplug messages with a list of metrics in a very, very simple way. So there's no further coding needed. And again, you can store and restore by saving and reloading this controller configuration here.
Perfect. Yeah. So I mean, for those who have just joined us here, so basically, I've got a Sparkplug device here running this implementation of a Sparkplug Edge of Network node. So currently, the configuration is set at 1,000 millisecond scan rate. So what we're going to do is to show how the Edge node is able to receive commands to adjust that value, and then later on we're going to show you that how that is actually implemented in code. So for now, we're going to show you how it reacts. So as soon as Jens sends that messages, we're also going to see it show up on my console here.
Yeah, and I would we can switch back to your console, and in the background I will publish this message when you're ready. But
yeah,
I think
hopefully we can
find a way to zoom in because it's really, really small.
Okay, let's see. Oh, don't want to break things here, but let's see. Let us know if it's too small. But Paul has already mentioned that this is small. Let me see. Okay, let me see if I can move.
This looks good.
Yeah. Okay.
Okay, I will publish the message to compressor 1 then. So
okay.
You see it states that a message has been received. The message is decoded to get a visualization here, and then it stops the data scan service and restarts with the new value of 5,000 milliseconds, and now the data is published any 5 seconds or 5,000 milliseconds.
Okay, perfect. Now I think maybe Jens, do you want us to jump into the project to explain how all of this is implemented?
Yes, sure. So I will start. Let's have a look at the README of the project. This will also explain or introduce of how to set up basically and which components are involved here. So if you would like to start with this project, you have to prepare your device first. So it contains a Raspberry Pi 4 and a Raspberry Pi SenseHead add-on, which is just placed upon the Raspberry Pi and connected via this these pin connectors. And it contains these 8 to 8 RGB LED matrix to allow some visualizations, and we are using the humidity, the pressure, and the temperature sensor then. So first of all, we have to install Java on the Raspberry Pi because, eventually and obviously this is all written in Java, so we need a runtime environment. And what we need in addition to that is to install the SenseHead software. This is a Python library, and my project contains a Java wrapper that calls these Python and executed Python codes on the Raspberry Pi, and later then parses the value from the output that is captured. Next thing is to clone, build, and install the the project. So you can use Git to clone this this project, and then use Gradle. This is a Gradle project, and Gradle is used to build the artifacts. Yeah, this is the basic configuration that comes with the project that Kutzai has already introduced. But yeah, I think Paul is more happy yet because it's a bigger size font here. And
yeah, perhaps you can go through these
yeah,
elements again.
I can go through very quickly. So there's a logical device name for this. Here, obviously, this is the data scan rate, the broker address, and the port, the client ID. You can set if you want to use TLS, and also username and password. It's disabled by default. Followed by the Sparkplug settings. So basically, the group ID, the Edge Node ID, and the device ID. These information are stored in a properties file, which is passed as an argument to the run script that is generated by the Gradle build to parameterize the application. So after you have executed the build command, it will there's one big, not that big, it's about 40 megabytes central application that it's a shadow jar, so-called shadow jar in Java. So it depends all the dependencies and anything this application needs to run. And also Gradle will take care that there's a bin folder generated with a start script for Linux and Mac, and also for Windows, this .bat file here. All you have to do next is to create a folder structure like this by copying the whole artifact build here. Eventually, you'll rename it from Shadow to Sparkplug EON. There's a lib folder, the bin folder, and you can also place the configuration file here within the Sparkplug EON folder structure. And after that, you can run the device application by calling the start script and passing the properties as a parameter here. So down here, these are the commands that this node currently understands. So there's a shutdown, device shutdown, and a reboot command. Rebirth will tell the Edge of Network node to reinitiate. So it will send a death message, and then the full birth message again. There's a command to resend all of the current sensor values by disrespecting the report by exception mechanism. You can run or start and stop the data service by sending a Boolean true or false to toggle the data service operation. And we've just demoed the data scan rate. Oh, there's a typo here. I've recently changed the value from long to int, so I have to modify the README. Yeah, we basically demoed the data scan rate changed via an Sparkplug command. And there's also a description of the node properties that are provided, and the sensor values. That's it, basically, for the project.
Okay, perfect. Yeah, so I mean, this project is also going to be made public, and there's a blog post coming. So if you are watching this perhaps on YouTube after the fact, we'll have this on the link the link to that blog post on the description to this video. But I guess now what we need to do is to perhaps jump into the code, right, to see the actual Java code behind this implementation.
Yes, we can do that. So I will switch to my IntelliJ. Just a sec.
Again, if you've got any questions, feel free to drop them on the chat here. We're happy to answer your questions as we go along.
There you go. So this is the actual code here. So the reason why I've started this project, I was looking for an example, a Sparkplug Edge of Network node, to get an idea of how to really implement a device firmware like this. But I was not happy with all the examples I found on the internet, and also the Sparkplug working group has the Tau project of the Sparkplug working group only contains a very simple device implementation. So what the reason why I've started this is I wanted to get my hands dirty and wanted to give it a try, and wanted to create an Edge of Network node for my Raspberry Pi hardware that I have refound in my stuff. Yeah, the reason why there's a comment why I have chosen Java. So it's my preferred language, and it was just an easy start point for me. But what's next on my list is also to create a GraalVM based binary version of this code. So that my idea is to have just one binary, that universal binary that is able to run almost everywhere. Then maybe also on a microcontroller. I don't know if this would fit. But yeah, again, the reason why I've chosen Java here is so that's my major language.
So it's maybe just to quickly jump in there, Jens. So, but like say for someone who's using another language other than Java, would this also work kind of like as a framework to show exactly how to go through with the workflow of developing this Edge of Network node?
Yeah, I think it might be helpful to get an idea of how to start and what to respect in the implementation.
Okay, perfect.
Yeah, perhaps in the future there will also be a Python version available on this. Yeah, so the heart of this implementation is the Sparkplug Edge of Network, or Sparkplug EON class. This is the idea behind this is to create an abstract class that already implements all stuff that is that any Edge of Network node should be capable of. So, for instance, to connect to the broker, and then subscribing and publishing the right to the right topics, and publishing the right messages in the right order, so that a developer who is developing a specific Edge of Network node for a specific hardware does not have to re-implement all that stuff and reinvent the wheel. So I would like to. So my goal here was to create a starting point with all the boilerplate code that has to be used on any edge of network node. That's why this class has basically anything on board and also implemented as much as possible what any Sparkplug edge of network node needs. So there's an MQTT 311 client that is created, and you have a look at the connect method here. It's following the Sparkplug specification by first connecting with the death message and then subscribing to the command topics. And then publishing the birth message, and after this the device is switched on and has notified the primary application that it is online and available, and with the birth message the primary application also is educated of the device capabilities. The URL of the project will be shared in time, but it's not a public repo yet. So I've still have to spend some effort in make it rock solid, and also make sure that there's a proper test, proper testing before opening it up to the public. So stay tuned for the updates when this will be available. So also the creation of the death or creation and the publishing of the death and birth messages is already implemented in this within this class. So the actual device implementer or developer does not have to take care of this, and this is all running in the background. And there are some abstract methods here, for instance, how to handle command metrics, and how to get the changed metrics, and also the updated values map mechanism that I'm using here. These are device specific. So this up to this point, you don't know which metrics are or which commands are actually supported by the implemented device. This is done in this case in the SenseHead Sparkplug Edge of Network Node class. This extends the Sparkplug EON and make use of the already implemented code and stuff and functionality. So some initialization of the different maps, the command map, the properties map, and the values map. Yeah, these are the implementations then of getting the changed metrics in respect to the report by exception mechanism. Yeah, calling the SenseHead wrapper to get the in this case the humidity, the temperature, and the pressure value from the actual sensor devices. Here is the implementation of how to handle the command metrics that are supported. Yeah, and the execution of the actual commands, so like shutdown, reboot, rebirth, and so on. So again, my design idea here is that if a developer has a different device or additional or other sensors connected, the point of implementation or focus of implementation is this implementation class of the abstract Sparkplug EON class, to save a lot of time and to focus on what's really supported by the actual device. Yeah, so I think that's it with the high level overview of the code and the software design here.
Yeah, absolutely. Thank you so much. Yeah, so again, as Jens mentioned, this project is going to be shared, right? So watch this space probably within 2 weeks or so, just to give you maybe a rough timeline. So maybe if you are already watching this video after today, right, after the date of recording, you can check out the link, the URL on the description of this video. So I think we've still got a few more minutes to go here. If there are any more questions, please drop them on the chat. So maybe while we wait for some questions, Jens, do you think we can kind of like showcase some way to send commands to the edge of network node for those who have just joined us? So again, for those who have just joined us, I've got a Raspberry Pi Sparkplug Edge of Network node here sitting with me, and Jens has also
Me
got
too. The same
another
one.
one. And we're using MQTT.fx to send commands to these Edge of Network nodes and also to display the metrics. So maybe while we still wait for questions, let's see if we can send perhaps a rebirth. A rebirth is supported, right? Do you think that would be possible?
Yeah, so rebirth command.
So I can bring my console up and then you can.
Yeah.
Okay.
Again, I think you have to zoom in.
Small again. Yeah. Let me see if I can bring this here.
Mm-hmm. Okay, I will fire up a rebirth command.
Okay, there you go.
Okay, yeah. So rebirth message has been received here on MQTT-FX.
Perfect. So yeah, basically a rebirth command for those who are not familiar with the Sparkplug again is to ask the edge of network node to send all these birth messages. Again, you can send that command because this EON implementation supports that. Okay, so I see we've got a question from John.
Yeah, he's asking if the report by exception is handled by Sparkplug Edge of Known class or if it's handled by the functions that are actually acquire the metric data. So currently, it's the job of the your concrete implementation. It's not handled by the Edge of Network node. Because by now the Edge of Network node has no idea of the values that are collected. But I have already thought about implementing a generic mechanism to get the changed metrics. But this would assume that this Edge of Network node will only send a list of metrics, very simple metrics. So when it comes to complex objects that are possible with based on the put above schema, then it might be too hard to code this in a generic way, and you need a proper implementation for that. But when it just comes to a list of metrics, I think it's possible to implement the Sparkplug, the abstract Sparkplug EON class to support this.
Okay, thank you for the question, John. Okay, so if there's any more questions, please feel free to drop them on the chat. So maybe again, just for sure, maybe we can shut down my device. Jens, can you send a shutdown command?
Yeah, will do.
There you go.
So device shutdown, and I'm not actually sure if I have disabled this, because this in my testing, and this is not enabled yet.
Oh, okay, I see.
Let me try a reboot if this is working.
Yep, I can see my device should be rebooting.
Mm-hmm.
Yep, that works.
Okay.
So you can see there my device is rebooting. Okay, so if there are no more questions, I think we will end the live stream here. So Jens, thank you again for taking the time to come out here and show this project, and also for putting this project together. So this project again is open source. Stay tuned for when we share the URL to the project, which you can then use to implement it on your own, or if you need to kind of like build some hardware platform, or you already have some hardware platform, you want to integrate it in some machine, and you've been looking for ways to kind of like build that Sparkplug Eon functionality. I think this would be really helpful in that case. So again, thank you so much, Jens, and
Yeah, thanks for having me. Kutsai.
speak soon. Thank you everyone for joining, and thank you for your attention and your questions. Cheers.
Okay.